implementation of a rule-based system to perform assessment of COLREGs on board maritime autonomous surface ships. My name is Koch. I'm from the Fraunhofer Center for Maritime Logistics and Services in Hamburg, Germany, and this is our contribution to the ICMASS 2022. Let me start with the agenda. I'll give you a short introduction to MASS and COLREGs in the MASS context. We will talk about the operationalization of COLREGs, our strategy, and the evaluable situation statements that we've developed. I'll give you a short introduction to the implementation of the situation statements that we've developed, the fact base and the rule base that we've developed, and at the end I'll give you a short conclusion and an outlook. Let's start off with a short definition of a maritime autonomous surface ships. As per ISO, it's just a vessel to be controlled by automation without human assistance. And usually these systems consist of multiple subsystems performing dedicated tasks like decision-making, path planning, and situation assessment. Role of COLREGs in itself, of course, they describe behavior of vessels in encounter situations. They describe how these situations shall be resolved, usually by two vessels. They're split into multiple parts. We focus on part B of the COLREGs, which describe the steering and sailing rules. A few of the key challenges that you'll always encounter when working with MASS and especially the development of systems capable of doing it is the compliance to COLREGs, to watch and standing orders. You have to translate the human readable rules written in COLREG into a valuable rule sets, so they have to be machine readable, and you have to also be able to integrate like federal regulations, for example. Our strategy for the operationalization of the COLREGs in itself is just that we want to transform the written rules into valuable situation statements. We want to connect the statements of the statements that we've developed into rule sets, and these rule sets will be a step-by-step integration of all the rules written in COLREG. Our methodology mainly was that we took advantage of the sectors already defined in COLREG, which you can see on the right side, and that usually, or that all vessels fall in one of four sectors: ahead, astern, and port and starboard sector, and that with modeling these sectors and modeling relative motion between the vessels posing and how they face each other, you can model all the typical encounter situations that you need, like crossing, head-on, and overtaking situation. The operationalization process in itself consists of these annotations that we've developed, which you can see on the right side in the table. This is just an excerpt. You can see the full list in our paper. Just a few abbreviations used in this to help you understand it is that O denotes the observer, in our case the own ship. Since we look at relative motion of vessels to each other, we always have to have a point of reference, which of course in our case is the system, or is the vessel the system is deployed on, which is the own ship. Every other vessel is a target vessel and is a vessel observed from our own ship. And you see a few of these mathematical operations that we've used, like INV for inverse, speed across, describing the relative bearing change between two vessels, and speed along, describing how two vessels move closer or further away to each other. A few helper functions, also more detailed in the paper in itself, is like a bearing function giving you the bearing, a heading function giving you the heading of an entity, and of course all courses measured in degrees via tiered to nautical units to ease the implementation and understanding of these rule sets for anyone familiar with this topic. You see the epsilon parameter. This for us is just a design parameter modeling uncertainty, usually from sensor fusion. This is not detailed in this paper. It's a topic for future research. It's just included for sake of acceptance, or to show acceptance from our side that it's needed to model these, since we are working with some thresholds and defined sectors, so it's needed to have a look at uncertainty. The operationalization itself is mainly focused on the assessment of relative vessel motion using change in bearing and change in distance. We are working at a relative approach as already introduced. So on the left side you see senior motion statements which describe how vessels are moving relative to each other and how they are facing relative to each other. And on the right side you can see typical passage statements. Passage meaning that a vessel is passing ahead, a vessel is passing close, or a vessel is passing astern, which both of these you can combine to describe COLREGs. The fact base that we've used more detailed in the paper. Just a short overview shows you that we've modeled vessels and described, or that we've modeled vessels as every vessel in our scene, and the own ship is our observer. So it's the ship the system is deployed on to have a point of reference and a point of view, because we need this to assess these relative situation statements. Between every pair of vessel and own ship, there is a situation. A situation consists of all of these annotations that I've introduced, like a target is passing ahead of our own ship, a target is passing astern, it's in the starboard sector, port sector, ahead sector. And when you combine all of these annotations, like a vessel is on our starboard side, a vessel is passing ahead, and a vessel is threatening us, so it's coming close, then it's an encounter situation for a crossing courses situation. And combining these exactly into these rule sets to assess that the situation is either like a crossing courses or a overtaking situation or a head-on situations, you combine all of these evaluable situation statements or annotations into rule sets by connecting them using Boolean algebra. On the right side, you can see an example implementing a risk of collision in the beginning. So if a vessel is passing close and they're not aligned, so they're not moving in the same direction, then it's a risk of collision. And overtaking in itself is modeled that a vessel is overtaking us. Of course, if it's astern, it's not moving away. We are overtaking another vessel if we are aligned with this vessel and we are coming closer with the vessel. So we are moving into the same direction and we are inbound to this vessel, which would mean that we are overtaking this other vessel. With these two situations, like vessel overtaking us or a vessel being overtaken by us, of course, yields in the end just two possibilities. Either that a vessel is a give way to us or a vessel is stand on relative to us. If we take the vessel is overtaking us, then of course the vessel would be give way to us since the vessel is overtaking. It is not a privileged vessel, which privilege in our case was the modeling for responsibilities. As already said, more details in the paper. There you will also see the full list of all the statements. And of course, the vessel is not a head-on or a crossed vessel. A short conclusion and an outlook to the end. We implemented a call rule set, which I just gave you a short example for rule 13 overtaking. We also implemented rule 14 for head-on crossing courses. We implemented the responsibilities for give way and stand-on. And of course, the responsibilities between different types of ship for rule 18. We implemented these rule sets in the form of a knowledge-based approach. So we used a rule-based expert system. We formulated the rules using the rule sets that I've shown you to build a system capable of adhering to the COLREGs introduced. For further work, it is planned that we contextualize our information with spatial data from, for example, electronic navigational charts, which would also allow us to create further annotations, giving us information if a vessel is inside a TSS or if a vessel is privileged inside a narrow channel, for example, which would allow us to also implement COLREGs Rule 9, narrow channels, and COLREGs Rule 10, traffic separation schemes. We can also, or plan to also take this one step further, which is to create data labeled with the annotations. It's always annotations the same as these evaluable situation statements. So every relative motion between two vessels opposing is described using these annotations. We can create data which is labeled with these annotations and can use reinforcement learning approaches, for example, to train agents to find more efficient collision avoidance strategies that we could not come up with our own, or we couldn't use, or we couldn't come up using conventional methods used up to today. And due to the defined set of annotations, since all the labels that we would create are defined in our list of evaluable situation statements, this would also increase or simplify verifiability of such a system, or at least it could greatly enhance verifiability, making it possible to use machine learning approaches in using COLREGs in a autonomous context, which of course would be a huge leap forwards. I thank you very much for your attention. If you have any questions or further inquiries, please feel free to contact me or one of my colleagues directly. Otherwise, I can just recommend to read the full paper to get a full understanding of the work that we've did and to get a full insight on all the details and to get a full list of all the statements. Thank you very much.
Do you have any questions for the speaker in the audience? I have one question I would like to ask myself. Edmund Brekke from NTNU in Norway. I wonder, like one of the things we have seen a need for when we work with the COLREGs in automatic anti-collision methods is that you can come in situations where you have multiple vessels and you are in giveaway for some, and for some vessels you are stand-on. Like, do you have? I didn't see that as that part of this framework. How do you deal with that kind of situations?
So first of all, thank you very much for the question. So if I understand you correctly, your question is how we would handle that our ship, like the own ship, or the ship the system is deployed on, as I've described it in the presentation, would handle like, okay, I'm stand onto this and this vessel, and I'm give way to other vessels, correct?
Yes.
So you have to see, or the thing that, or how we view it is that there's always a situation between two vessels, and the two vessels is always our own ship and any other vessel in the scene. So in any of these situations, we just view as individually. Yeah, so we do not view the whole picture, but any interaction between us and any other target vessel individually. So we could just say, okay, if we apply the rule sets that we've developed to this vessel, this just means we're stand on. And for the other vessels, this means we're give way. So at the end, our vessel will have like different responsibilities that it has to adhere on. And in the end, in the COLREGs, it's just written that if you have to give way, that it's just higher priority than to stand on. And when we do further steps or further services in the system, perform like, let's say, path planning, or decide on which path to adhere to, of course, they have to look at the give way responsibilities first before looking at any other responsibilities to plan the path accordingly. So that's how we model this multiple responsibilities to multiple vessels at the same time, or that's how we view it, and that's our approach to solve it.
Okay, I think that that answers my question. So please present yourself and your institution.
Paul, I am a marine surveyor.
Hello.
And I do many surveys on behalf of the underwriters. When there is a case of collision, we always consider 50-50 for a start. That means you collide each other, you have 50% responsibility, and another, you collided to the guys, it's another 50%. So the remaining 50%, which is more, which portion is more? For example, if the guy, if another ships collided on the port side, starboard side of the ahead ships, we consider him is another 25%. Is there a possibility that we give all these data to you, and can you determine the responsibility of which vessel carries more responsibility on the collision side? Is my question clear or not clear?
So let me rephrase it. So if I understand you correctly, when you look at, let's say it came to a collision, you look at all the parties involved and try to assign like percentual or percentage-based contribution to something that happened based on all the vessels in the scene, correct?
Yes, that's correct.
So although not the focus, or we have not looked at it at all, just from a logical point of view, of course, when we have some more rules on how these percentages are built up, it would be no problem for us to take a system like this to not only perform just assessment on the responsibilities itself, but of course to enhance the data or infer further information like, okay, how many vessels involved, to how many vessels did I have to yield, for example, or how many other vessels had to yield to me. And of course, we could derive percentage-based distributions from this and could, in the end, just produce a list of the vessels involved and their contribution to a collision, just based on all the responsibilities that each individual vessel had to do. So if you want to know further information, you can maybe contact me after the conference and maybe we can talk about this in more detail. But I think in general, this would also be a really nice usage of what we've built, and maybe a nice application that we have not thought about before. I hope that answers your question.
You see, the key point is, as a surveyor, we normally determine which ship has heavier responsibility. And the damage claims from each other is proportion to whatever the percentage it is. Can you hear me there?
Yes, yes, I can hear you.
So with all the, if we give you all the informations, then your company or can fit into your system and determine the percentage. And is it your opinion will be legally binding? That means, well, for example, you go to the arbitration, whether your opinion stands legally.
I think the legal question is just, that's a whole other topic, just to keep it short. So our approach is we try to adhere as close and as literal to the COLREGs and as literal to the text written in COLREGs, so we do not try to bring in our own. So I think if you would do a review of it from a legal perspective, that the chances would be pretty high, that what we've built could be something that you can transfer into a state where it would be legally binding, just because we try to build our system to be the exact machine representation of what is written in COLREGs. So I think there is a high chance that this could be something that one could achieve with the system that we've built. At the moment, we have not looked at the legal side of things, which also comes to verifiability and a whole other range of problems. But I would say the approach itself is viable and has the possibility to do something like that. So yeah, I think there is something to be done there with what we've built.
Do you have this kind of experience before?
No, we have not. We're currently not.
When the surveyors or the insurance people approach.
I apologize, but we have to stop. We have to move on to another question quite soon.
Okay, I stopped my question. Sorry about that.
We have one question from outside that I would like to take. So someone has asked, does your rule apply to both small ships and big ships?
So that's a question of definition of small and big ship. So right now, all the rules would apply to ships covered by COLREG. So more or less all the ships. So from a COLREG point of view, there are just ships. And if you look at like a sailing boat or, I don't know, recreational vessels, for example, there are some special rules covering this. But since we are implementing all the rules, effectively all the ships are covered in the end. So we make no distinction between small and big ships. We cover all ships that are covered by COLREG and to the context that COLREG applies to.
I just can comment myself. I guess the underlying thought behind the question is that when you see in practice that when you have small boats and you have a big container ship, that small boat will never try to challenge a large ship.
Yes, but I mean, legally, or let's say logically speaking, it's defined in COLREG. There's a rule for it, responsibilities, which kind of describes how something like this should be handled, or for example, in our channels, it's also described how stuff like this should be handled. Currently, of course, the system is deployed on big ships, and we kind of view it situations between commercial vessels, merchant vessels. And we haven't particularly analyzed how situations with smaller recreational vessels, let's say 50 meters or less, 15 meters or less, would work in this framework. But theoretically, there should be no problem with it, and we make no specific distinction at the moment.
Let's thank the speaker again.